Space Science with Python is a nice, great project of mine, but the projects are exceeding the size and it takes more and more time. Now, in this short video, I would like to introduce a small side project called Compressed Cosmos. And what's all about? Well, let's start. Space Science with Python is a nice, great project of mine, but the projects are exceeding the size and it takes more and more time. Now, in this short video, I would like to introduce a small side project called Compressed Cosmos. And what's all about? Well, let's start. All right, let's switch to our open source tool, Stellarium. So some of you may know it, some may not. Stellarium is an open source software, a planetarium software where you can, for example, display the stars and so on, planets, galaxies, and what have you in the night sky, and also the day sky if you would like to, for example, see where the moon is or so, or the sun. But again, don't look into the sun directly. It's not good for your eyes. Anyway, here in this tool, we can set up, for example, the location, the time, and so on. And I was thinking, well, there is like one thing coming out now here in July. It's Saturn. Yeah, Saturn is the ring planet. We see here, if we zoom in, that the rings are not that visible now. There we have almost an edge view, so pretty boring, so to speak. We have some of the moons here as well, like Titan, like Rhea or Mimas. And the thing is that with the small Python code I would like to create, I would like to compute the rise time of Saturn. So of course we can use Stellarium and have a look, but I think using Python, using maybe less than 100 lines of code is pretty interesting for those of you who are new to this channel to see how we can compute this stuff in this side playlist called Compressed Cosmos. Now, without further ado, I would say let's switch to my GitHub repository, and there we have this one script only with one notebook cell. The cell here above is used for installing stuff, and you simply need to click here on Open in Colab. So Open in Colab is opens Google Colab. If you don't know, Colab is a tool that allows you to compute Python code and machine learning in the cloud. There are different plans, like this one is, there are ones for free and one that costs money. Again, I'm not making any advertisement. I think it's pretty easy without any heavy installation. And for those of you who are new to coding, to simply start with coding stuff. And first of all, we need to install some things that are not installed per default here in Colab. So let's play. We have to run it, and then it installs 3 things that are related to our code. Because we would like to compute the rise time of Saturn, we need geolocation information that we can use with GeoPy. With FM, we compute the position of Saturn, and with the time zone finder we can also use human readable text, let's say, to determine our time zone. So we will see what we do in the next code section. Now everything is now installed now, and in this notebook here we have almost, I think, 80 lines of code. So this is pretty compressed as the idea, as I would like to do, how to say it, well, as I intended. Yeah, it's the idea of this Compressed Cosmos to have everything in one notebook. Now here, this notebook, let's go a little bit through it. There's a small function called simply Saturn rise time. The location can be provided as for example, you can write the city name, for example, or in a tuple, the longitude and latitude, if you like. And then it checks, for example, first if your location is a string, like the name of the city, or if it's a tuple. And you have to be careful, the tuple needs to be provided in radians, not in degrees. And here in this part, first we check for the location, and if the location, like for example my hometown Stuttgart in Germany, we will then compute the longitude and latitude, and then it will also be printed so that we see whether the results make sense or not. And then afterwards, based on our location, the time zone is being determined. And then with the set time zone, we can then calculate Saturn's rising time, which uses the FM library. So it simply says fm.saturn observation time. Pretty straightforward. And then it later converts or considers also the UTC timestamp into the local timestamp, because UTC is like the, let's say, the Greenwich time. And of course, you are interested in your local time. You don't want to calculate back and forth. Maybe a small improvement would be to provide also the values in degrees, not in radians. But maybe this is something for you to find out how to do it. It's pretty straightforward. You can also use the math library with degrees, but as you like. Now this exception here, the circumpolar error, what does it mean? Well, imagine you are at the North Pole and you'd like to compute the rising time of the polar, of the northern of the polar star. There is no rise time, it's always there, so that would cause an error because it's always making, let's say, circles in the sky and it's never rising or disappearing. Now here we have the small short user input part, so if we execute it, let's see here what happens. We get a small input window, pretty simple. I can now write the city I'm living in, Stuttgart, for example. It computes the shows the longitude and latitude. Oh, wait a second, this is now converted. I have to correct the script. Don't worry, when you get it, then you have the improved version. And here it says the Saturn rises on the 1st of July at around midnight. And I would say, let's check it out. We are here on the 1st of July, and I would say we are going back in time a little bit. Yeah, it was around 0:30. And here on the left side, with all the weird, crazy parameters, we have here the altitude. So the altitude implies or says where Saturn is above or below the horizon. It's now a few arc minutes below. So let's go. And now around 0:33, we have our rise time. And this corresponds nicely to what we computed. Now I would say let's redo it maybe with something else. Maybe New York City. Now it also computes the longitude latitude values, again inverted unfortunately, and it's right before midnight. So I would say we go back to Stellarium, we go to the left hand side, we go here and search for New York City. There we are. And then we have to go, I think it was almost midnight, right? 23:59. There we see the text already. And the altitude you see already above the horizon. Yeah, so if we go back in time a few seconds, we see, yeah, 23:59. Looks pretty feasible. So I think this is a pretty nice script you can go through and learn. And yeah, I think this is a very nice small script of this compressed Cosmos tutorial. Well, I hope you learned something, and I hope this is also helpful to have this small compressed snippet. So I would like to continue with this beside my Space Science with Python project that are getting bigger and bigger. So maybe publishing there only once a month or so. And here I can show you more tricks, more code snippets in a shorter period of time. This was a very simple example, but I think in less than 100 lines of code, pretty useful. Please write what you think about it. I would then start to, yeah, I would say randomly creating some codes of interest, some things that I know, maybe with different libraries to show you all the varieties, all the libraries that are out there for you to start with very small snippets. And yeah, just use some cloud solution if you're not very familiar with installing Python on your local machine, and enjoy the space science stuff.